Alright, today we're going to be working on reviewing solving equations with variables on both sides and solving for a specific variable. And did we have to finish up 0.4 at all, or did we finish that?
I'm not sure.
I think we finished that. That was the clearing fractions, right? I think we did that together. Yeah, I remember we did that part together. This is what we've been through. This is what we just quizzed over. Was the first three sections there. Okay. Then we went into 0.4. And we did this part, I believe, right? At the bottom is this page.
Yeah, we did that.
Okay, that's what I thought. Okay. We talked about clearing these fractions. Just to review, we picked whatever number that all of these denominators would go into, and we multiplied both sides by that. Remember, we did this in this middle step of distributing there. So, for example, 2, 6, and 3 all go into what number? 18, but do they all go into a smaller number as well? 12. They all go into 12 too.
6.
And 6, right? So let's pick the smallest number, because the smaller number we have, the less we have to multiply. And we like that. So it's kind of, you look through, oh, 18 works, okay, 12 works. Oh, 6 works, okay? So multiply by 6, and multiply by 6. Now here the important part is we multiply this 6 to both of them, okay? So we have 6 times 1 over 2 plus, that plus sign right there, okay, that plus sign just gets brought down, 6 times a over 6. We have the equal sign. I'll make sure that's an a instead of a 9. And then I'll just redo that. That's pretty bad. Equals 1 over 3 times 6. Now it's easiest for us to think of these 6s as 6 over 1 when we're dealing with fractions. So we can make them all 6 over 1. Okay, we did this already before. We're just going back over it. And so this 6 and this 2, since they're multiplying and they're diagonal, we can cross reduce, right? Cross reduce, cross simplify, whatever you want to call it, of those two. And so what goes into both 6 and 2? 2. How many times does 2 go into 6? 3, so that becomes a 3. How many times does 2 go into itself? 1. So 3 times 1 is 3. And do we have to put the over 1 part? No. Okay, so we got rid of the denominator. That's what we wanted. Okay. So here in this problem, okay, 6 and 6, what goes into both of those? 6. And they both go into each other once. So what are we left with? 1 times a is a. So we're left with a right there, over 1, shown on the right. Equal sign over here. What goes into both 3 and 6?
Well, 3 goes
3, and it goes into 6 twice and 3 once. So 1 times 2 is 2 over 1, which again we don't have to write. Okay, so now this problem, is that a lot simpler than this what we started with? Yeah, we don't have any fractions anymore. That's nice, okay? So remember we did that by picking what number these all go into, okay? It's called a least common multiple, okay? Least common multiple. Lowest, least common, they share it. Multiple, they multiply to, okay? And then we multiply each of these, each and everything by it, okay? And so now we subtract 3 to get rid of that addition of 3. And we have a is equal to what number? What kind of 1? Negative 1, because the 3 is bigger. Different sign, so you subtract 3 minus 2 is 1. It's negative because the 3 is bigger, right? That's a recap of what we did. Okay, let's go on to 0.5 now. So let's flip this page. Okay. Solving equations with variables on both sides. Okay, so in the variables on both sides. So we have the same variable s, but it's on 2 different sides now. We have 8 plus 5s is equal to 7s minus 2. Okay, Gracie. Combine like terms. Okay, so I'm actually going to rephrase that a bit, but I love the idea of what you're saying. Okay, I'm just going to rephrase that slightly. So we like to use the term combine like terms. We like to use that phrase when things are on the same side of the equal sign. So when things are on the same side of the equal sign. So like in previous problems, for example, let's look here. So when we had like 5d plus 7 minus 3d equals 8, 5d and negative 3d are on the same side of the equal sign. They're both on the left here of that equal sign. So we call it combining like terms because you just add them however they are. Because you do 5 plus negative 3, oh, that's 2. Okay? And so we call it combine like terms in that case. But when we have them on different sides of the equal sign, we like to call it, we like to use some different phrasing there just so we don't confuse ourselves, okay? Oh, hey, Mr. Mellon. Anyway, so when they're on different sides of the equal sign, we do need to get our like terms together. So 5s and 7s are an example of like terms. But can we just add them right now, 5 plus 7?
You
No.
would have to,
We have to move one of them to the other side, don't we? Okay. Does it matter really which one we choose to move? Anthony's saying, no, I agree with him, okay? Now, typically, excuse me, these are both positive right now, right? So in order to move either or both of them, we have to subtract, wouldn't we? Okay. Hey, oh, thank you so much. I appreciate it. Boom. See you guys. Okay. So we'd have to subtract either one of them to move them, right? So let's think about this. Would we rather take 7 minus 5 or 5 minus 7? You'd rather do 5 minus 7. Okay? So 5 minus 7 would look like this. What kind of number would we end up with?
Oh, I mean 7 over 5.
Okay, I had a feeling that's what you really meant. Okay? So we'd rather subtract the little number, right? We'd rather keep it positive. So let's subtract both sides by 5s. We think through that and we say, oh, well, if we get to choose, let's move the smaller one to the bigger one. That's what I would say. Let's move the smaller number to the bigger number. And I would prioritize doing that with the variable. So I would say let's move the smaller variable over to the bigger variable. I would say that's a good rule of thumb. You don't have to, but I think it makes our life a little bit easier and more straightforward. And I'm all for that. Okay? So what's 5s minus itself? 0. So what's the only thing we have on this left side of the equal sign? 8. So it's 0. So we don't have that. So 8 equals, what's 7s minus 5s? 2s, and we also have this negative 2.
So we're just treating this like it's just
Normal problem.
just like the variable.
Yeah. So, well, it's not like it doesn't matter. It's just we have to get them to be the same. We just put all of the s's together, and now this is one of our normal problems, right? We know how to solve this, right? Okay. What would we do?
You would add the 2
You
to both sides.
can add 2 to both sides. Because you want to get all the normal numbers together now. So our first step was to get all the variables together. Now we want to get all the numbers together. In reality, you could switch that. You could do the numbers, then the variables. I just think it's easiest for us to think, let's get the variables together, now let's get the numbers together, okay? So you add 2 to both sides. What's 8 plus 2? 10. We have 2s still. We haven't done anything with that. And what's negative 2 plus 2?
0.
0, okay? Now, this is just a one-step equation now, okay? This is one step now. What do we have to do?
Get rid of the 2.
Get rid of the 2. How do we get rid of this 2? That's the question.
Minus 2.
Not minus.
Add 2.
No, what's up?
Divide 2. Divide.
Divide, because, okay, what would Mr. Cost last at WWMCA? I like that, okay? We said, okay, we need to get rid of the 2. How? That's the next question, okay? Then you ask, well, what's happening? Multiply is what's happening, so how do we undo? Divide. Algebra is a lot of undo, 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 undo. How do we undo this? Oh, it's multiplication, so we divide by 2. And we do it to both sides, keep it equal. What's 10 divided by 2? 5 equals, those 2's divide out, and we're left with s, okay? Don't confuse that this s, this is an s, and this is a 5. Okay? Questions on that? Okay, we are going to try the next one around. I would have said that anyway, so.
There you go. I think this is really bad, bro.
This is a little, so here, 7 minus 3 is 4, but it's in positive 4W. Here's the thing, where's this minus 4? Let's think about what's happening here.
It's gonna be 45.
So how do I do multiplication? Okay, let's try that.
Is this your favorite team?
Yes, it is.
What type of tea is it?
T.
Did you say tea?
Team.
Oh, I thought you said tea.
Must
Mustang. Green tea all the way. Like what?
No, how do you get this for? You, what? So you divide this out.
Let's
So
say
you
you
divide
got
it by 4, no? Is that 2?
Green tea. Healthy for you.
Watch your mouth.
It's the stuff.
But there you go, it's better. That's tiny. Let's think about this one here. Let's put the little fraction right there back into 4. Right, right?
It's actually
I'll
not.
keep going to both 2 and 4.
8, 2.
Just write it times 2 and 2. Okay, so the top of the fraction will be
You said write it down.
times 2 and 4.
So it's the same thing, bro.
That's 1 half. See how 2 over 4 becomes 1 half?
Negative.
So
2, 4.
which number is bigger, the top or the bottom? Bottom, okay. So that means less
Okay,
than
1 and
smaller
2.
than 1. Okay, so the bottom is bigger than the top. You just said 2 and 4. So if it gives an answer that's bigger than 1, like 2 or 8
Got
or
2.
4, you know, get 2.
What are you saying?
I don't know, like, that makes sense.
Alright, look, I got 4. I got 4 cookies.
Okay, you got 4 cookies.
And I got 2 more.
2 more. Alright, now, how much of those cookies make that much cookies? I can't.
2!
Okay.
Oh my
Is
god!
it double? Or is
It's
it
2 divided by 4.
Yes. Okay. So if I have 4 cookies,
Yeah.
I split them into 2 groups.
Yep.
How many cookies are in each group?
2.
Okay. So, and that is what of the original number? How much of the original number?
I'm not a math
Half.
student.
Half.
So 50%.
So you're left with 1 half.
Oh, dude.
I can't.
See, I even said that too. When you said, what's that? I said 1 and 2.
That's not.
That's still 1 half, because look, you said now divide those, and you said
I'm
what?
not meant to
You
be a
said,
math
how do you
teacher.
simplify those?
I'm not meant to be a math teacher, Mr. Costa.
I'm not. I'm meant to be a math student.
I'm meant to be a math student, Mr. Costa.
Why are your hands so cold?
I don't know, it's cold in here.
Okay, my hands are always
I know, I don't have a jacket.
So is it 1 half?
Okay, let's talk about this, okay? So, we said our first step was to get all the what together? Variables. All the variables, okay? We need to get this 3W and 7W together. We're on different sides. So we say, okay, we want to move which one to which?
3 to 7.
Move the 3.
Yeah, move 3 to 7 because it's smaller, okay? The other tip is that if one's negative, we haven't encountered that yet, but if one's negative, you want to move it negative because you add, okay? So we move the smaller one. That's going to leave us as positive. So we move this 3W how?
Subtracting it.
Subtracting it because it's currently adding to 2, so we subtract, undo that. So 3W minus 3W.
0.
0, we're left with 2 equals what?
4.
4W. Now we say, okay, what Mr. Collins will ask, okay, how do we get W by itself?
Because they're multiplied.
Divide, because we undo multiplication. Okay, we think about consequences of undo, undo, undo. Divide by 4, divide by 4. 4W divided by 4 is just going to be W. Take that dub. Okay, 2 over 4. Okay, let's think about currently right now. Okay, which number is bigger, the top or the bottom of this fraction?
The bottom.
The bottom. So are we going to end up with a whole with 1 or anything bigger than 1? No, because the bottom number is bigger. Anytime the bottom number is bigger than the top, it's going to be a number less than 1. Okay, so if you end up with a number 1 or bigger, you did something wrong. We need to check. Okay, 2 over 4 is not quite a full number. If it was 4 over 4 or bigger, that'd be a whole number. Okay, but it's not. It's smaller. So we have less than 1 whole going on. So we look at this and we say, okay, what goes into both 2 and 4 if we want to simplify this fraction?
2.
2. How many times is 2 go into 2?
1.
1. How many times is 2 go into 4? 2. So we end up with 1 over 2.
Why didn't you explain it like that?
Because I'm not a math teacher.
Questions on that?
We're doing this next one together, right?
No, it's
We'll
not
talk
good.
about it. Okay, so on this next one, it's a more similar setup to the first one than the second one because we have a variable and a constant, that's what it calls just a number, and a variable and a constant on each side. That's what we had here, a variable and a constant, a variable and a constant. Here, what's the difference though? We have
Fraction.
fractions. Oh, fractions, they scare us, okay? So, we'll get used to them here. So, let's go with purple, okay? Just like the Vikings, okay? So, right now, we need to move, we said what would be our first step? Getting all of the what together? Variables together. We need to get our variables together. Now, to get our variables together, we're going to have to move one to the other side, don't we?
Yeah.
Okay, so here's the thing. If we know we're going to have to move them, we've been moving with what operation to start with?
Subtraction.
Subtraction. So if we subtract fractions, what do we need?
Multiplication.
If you're going to subtract fractions, what do you need? Common denominators, okay? You can't, it is a little bit more, but it's the right word, okay? So it's just like if you're adding up stuff, okay, if you're adding up stuff, it's going to be tough to add a half and a quarter, okay? If you have half something and a quarter, it can be tough to add it at times, okay? Say how much you have. So you need to convert it to common denominators so then you can accurately add, okay? So, 1/2 s plus 1 is equal to negative, what is equal to 1/4 s minus 6? Here's a good way to think about it. Okay? If you're measuring something, okay, measuring something with like a ruler or tape measure, okay? And you know that it's, so far, you have 32 and a half inches, okay, of something. And you know that you need an additional 3/4 of an inch. That might be a little bit tough just to add. That's why you need common denominators to know, oh, I need 33 and a quarter inches, okay? You need common denominators to know how to get there, okay? This kind of stuff for fractions is useful, okay? And I'm going to use that approach just for you because I know you're an A-teamer, okay? And you like measuring stuff, I'm assuming, okay? Assuming that I can speak to you a bit more. I said measure, you're like, oh, okay, I've done that, okay? So that's why we need common denominators for different stuff like that. That's a skill that's very helpful, is just knowing how to interact with fractions like that. So we're going to have to move over one of these to the other. Hey, which one's going to be smaller, by the way? A half or a quarter? A half, right? Okay. If you're asked, hey, how much of a pizza do you want? You want half a pizza or a fourth of a pizza? I would hope all of you would say a half, right? Because you get more pizza. Okay. Another way to think about this: the bottom, which bottom is bigger? Over here. So that means you're dividing by more. It's going into more pieces. If there's more pieces, they're probably smaller pieces. Okay. And especially since the tops are the same, if there's more of the pieces and you're only getting one of those, well, I'd rather there be less pieces. Okay. Would you rather share with 4 people or 3 people or 2 people? Okay, 2 people. Okay. So we know we're going to move over the 1/4, but we need the common denominators. What's going to be our common denominator here? 4. So do we have to change this one?
No.
Heck no. Do we have to change the first fraction? Yeah. What is? How do we get 2 to look into 4? Times by 2. Now, if we times by 2 on the bottom, Gracie was saying we need to times by 2 on the top. Now, here's the nice part. Because we're just multiplying this by 1, because that's 2 divided by 2, right? Is 1.
Yeah.
Okay, because we're multiplying by 1 with my air quotes here. Okay, we don't need to multiply anything else. We don't need to multiply this 1 or this 1/4 or this -6. Earlier problems, like on this last, like right before we started this, we were changing the way all of this looked. So we need to multiply by 6. And because we didn't multiply by 6 over 6, we multiplied by 6 over what number? 1. And that will change it. If you multiply by 6, that changes it to a different number. So we have to do it to everything. But here, because we're multiplying it by something that doesn't change it at all, because it's just 1, and anything times 1 is itself, right? Just like if you add 0, it doesn't change it, right? It doesn't change it even a little bit. So you can add 0 all day long, and it's okay. So what's 2 times 1, guys? 2. What's 2 times 2? 4. Okay, 2 over 4th s, and let's just rewrite the rest of it, okay? So I want you guys to write this with me. So write the 2 over 2 and rewrite this part with me, okay? So I'll let you catch up real quick. Okay, then we're going to rewrite the rest of it because we haven't changed it at all. So plus 1 equals, then we're just going to keep rewriting what's there. In this case, 1/4 s minus 6. Okay, so now we said we're going to move which one across?
Negative, or the 1/2.
The 1/4, okay? And now this might even be easier to see which one's smaller, okay? Because what's going to be smaller if you have 2/4 or 1/4? Well, 1 is going to be smaller than 2 in that case because they're the same amount of, the same number of pieces, same size of pieces, they're both fourths. So how do we move this 1/4 s across? Subtract. It's currently positive. Notice the minus sign here. This part is positive. Another way you can think of this is a positive 1/4 minus 1/4. Well, that's what you get 0. And you get 1/4 out of this because when the common denominators are the same, you just do the top. So 2 minus 1 is 1. And if we just went to all this work of getting common denominators, let's not ruin it by changing the denominator. We keep them the same. We just went to this work. We're going to keep it the same. So we get 1/4 s, and then so far everything else is the same. Plus 1 equals negative 6. Oh, that jumped out of my hand. That happened yesterday in your class.
Yeah.
I know that happened yesterday in one of my classes. Okay, now is this a problem that we've done before?
Yeah,
I think this is a problem we've done before, okay? Sierra, what do you think our next step would be? We got all the variables together, what do we do now?
Subtract the 1.
Exactly right, subtract the 1 from both sides, okay? Because now we got all the variables together, we need to get all the constants, or just the normal numbers together. So 1 minus itself is 0, so it's 1/4 s. Negative 6 minus 1.
I'm
Those are
sorry.
this.
Could you re-explain that?
Okay, so we just, thank you for asking. So we just got all of our variables together, right?
Yeah.
So our next step is to get all of our numbers together. So we just got all of our variables together, now let's get all of our numbers together. So we're gonna subtract the 1, to move the 1 away from the s and to the negative 6. Okay, we just got all of our numbers together, whoop. Now we get all of our numbers together, whoop. Okay, so we're left with 1/4 s, and let's think about this. Negative 6 minus 1, do those have the same sign? So you add them. What's 6 plus 1? 7. And now this is positive or negative? Oop. Negative because they're both negative, okay? So remember, in multiplication and division, if you have two negatives, you get what kind of number? In multiplication and division, different multiplication and division, you have two negatives, what kind of number do you get? Positive. But in addition to subtraction, if you have two negatives, you end up with that negative still, okay? Negative 6 becoming more negative. So now, when we said rule of thumb here, when you have a fraction in front of a variable, what do?
You have to
Multiply by the reciprocal. Very good. The reciprocals are math word. Reciprocal is slang. So what's the reciprocal of 1/4? It's 4/1. So we multiply this side by 4/1. And if we multiply this side by 4, that's going to change this number. So what do we have to do the other side? Multiply by the same thing. Change that number to multiply by 4. And could we call this 4/1 if we wanted?
I mean, yeah.
But do you have to?
Um,
Okay. So that side would end up being negative 28. Very good. Positive and a negative multiplying as the negative. Now what happens with this 4 and this 4 with their fractions? They cross reduce. What goes into both of those? Okay, 4 goes into both of those and they both become 1. And so what are we left with on this left side? Just 1 times s. So really we just have s. So now we have s by itself. Are we done? Heck yes. Okay. Heck yes, we're done.
yes.
Okay. Questions on that?
I find that so funny.
The job?
Yeah, like, because they're, like, ages different. I don't know. I've always found that.
It's funny, yeah. So okay, so I taught. Did I teach you guys the job thing? Did I tell you guys about that? So I was at Omaha South, the high school, for summer school. I taught there the last 2 years over the summer. And so if you don't know, Omaha South is a largely Hispanic school. Okay, it's not all Hispanic, but there's a lot of the students there are Hispanic, and so a lot of them are Spanish-speaking students. And so now, like when I taught with them, I had them I interact with them, and I don't know Spanish super well, and so I'm far from fluent. Okay, I can have a few basic phrases back and forth, a little bit of dialogue, that's it. Now, I had like a few of my classes teach me like Spanish phrase every day while I was there too as well. But like I also joked to them and like when I found something that wasn't funny, I would just say ja 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 because ja 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 in English is this. But how would you pronounce that in Spanish?
Ha ha ha.
Ha ha ha. Because you pronounce the J like a ha. Like jalapeno is spelled with a J, jalapeno. But it's pronounced jalapeno. Okay. So for jueves, okay, which is what? That's Thursday, right? Okay.
Yeah.
Okay. Jueves is with a J, but it's pronounced ha. Okay. So so this is pronounced ha ha ha. But when I say ja ja ja, I'm laughing in Spanish. It's kind of like calling something a tortilla or a quesadilla instead of a quesadilla or tortilla. What? No, they loved it. They do that stuff too. Like seriously, like all the students there, like that I taught, like they do the same thing. Like they say like de nada instead of de nada. They say de nada, but they do it back to like English too, because it's funny. So I would say John, they're like, are you laughing in Spanish? I'm like, yeah. And so I only do it when it's like things aren't funny though. I'll be like, jala jala jala, let's move on, kind of thing. But anyway, jala jala. All right, grouping symbols. What are grouping symbols? No, symbols that group numbers together. How can we group numbers together? Parentheses. That's one way. Okay, we have parentheses. What's another thing?
Those box things that you can do.
Brackets. Okay. What have you guys ever seen any other things? What about that?
I don't know what that is.
Have you guys ever seen it?
Yes.
It's like a bird.
Oh yeah.
Okay. Those are called braces. Braces are called braces. And I put kind of the same name as what goes on your teeth. Okay. Braces. Okay. And there's also what's that?
I don't know the lines.
Absolute value.
Whoa.
Absolute value. Okay, which always makes something positive. Okay. So we have those different grouping symbols.
Why
Okay.
do they make everything positive?
Because it's absolute value is how far something is from zero. So how far is negative 5 away from 0? 5 from 0. Yeah, so that's what absolute value is defined as, the distance from 0. Like on the number line. So, when solving equations that contain grouping symbols, first, use the distributive property to remove the grouping symbols. Because our order of operation says what comes first? Parentheses, which really means any grouping symbol. We just call it parentheses. But any of these grouping symbols we treat like parentheses. That's what comes first, okay? So, should do what? Gold? It does kind of like the Dijon mustard. Yeah. So we're told that we do parentheses first, okay? So that means you do stuff inside the parentheses first. Well, can we actually combine 6 minus 2s anymore? No, because they're not like terms. This one has an s, this one doesn't. You can't combine them anymore. So we have to distribute this 3. This 3 on the outside of the parentheses here, that means it's doing what operation? Multiplication. So we're going to start out with distributing before we do anything else, okay? So distributing means that this left side is going to stay the same. We're not doing anything there. 8s minus 10 equals. Now, this is where we're doing some math. Distributing. You guys remember what symbol you often draw above it?
Just
The little loose. Whoop. 3 times s. 18.
I even wrote that down.
What goes next?
The 3 times 2s.
So we do 3 times 2s, which is
6s.
6s. But what sign goes in between them? Negative. How do you know that?
Because it's right there.
It's right there. Very good.
Get body.
Okay. Negative because it's right there. What sign would we have put if this was a negative 3 though? Positive because a negative is a positive. Now, after we distributed and got rid of those grouping symbols, got rid of those parentheses, is this just like one of those problems we had on the last slide?
Yes. Sir.
Okay. Let's go ahead and work on solving this one now. Okay. Remember our steps. Remember our steps. It's right above there.
We should do green next because we made money.
That would be straight cash.
see those turtles this morning? I don't know who it was. There was some teacher that was carrying around little baby turtles.
Oh,
I
I
think-
want a turtle.
I think she hatched them or something. I don't know.
Really?
There was like 4 or 5 of them in the school, like ice cream bucket.
No way. Where'd you see him at?
She's in the hallway.
Really?
Yeah, she was walking around and showing all the teachers.
It's pretty cool.
Dude, I had a turtle. Found it at the plasma pond swim club because I used to kind of live by it. And I go down there and catch these like kid-sized bullfrogs and I throw them in this pool I have with the turtle.
Yeah.
Well, that turtle was eating the frog. Like, oh, it was kind of scary.
That's weird.
I don't think I've ever.
Dude, I think I'm getting sick again.
So you.
Is this where we
So
take the
yes.
one or the like 8S isn't it? It's a 2S. Like where you move sides of them.
Yeah.
Now, which one of these is smaller, 8 or -6?
Like what? 6S? I had it right.
So let's move to -6. How do you move -6 across?
You had it.
Yeah, you add 6s.
But you do that to both sides. Do that both sides.
Now what's hiding it? What's b plus 6?
18. Did you say yoga? I take yoga for those. I'm a personal trainer.
Very good.
I'm a personal trainer. Hold it, but you smoke that when you drive by.
There you go. No. What's up, my home dog? Are you checked out? What your shirt said? Don't be sorry. There you go.
You divide it.
Oh, shoe case.
That's a new one.
Said you're welcome.
Brady, how was your math test? Pretty good. It's fantastic. How did I do your day? I'm sure. I helped you grading fair warning. We did take a quiz. So I'm gonna have you I'll have you do that quiz on Tuesday if you're excited. Keith actually didn't win.
Yes, you definitely did.
Okay, I take it back.
Yeah, I take it back because I need some help. What part back?
Yes.
Okay, cool.
See,
Wait, get to where.
I know, look, you just got checked, I'm done. So I need to see if we got the same thing. What'd you get? Thank you. See, now we got the same thing, I put it in the box. I'm just gonna sharpen my pencil real quick.
Brady, you want to finish?
Can I solve that? Can I solve it?
Sure.
Whenever it is done, I guess.
Mhm.
Oh, you didn't drop it. Gracie threw it at you. Like, tossed it to you, and then you, like,
Yeah.
and then we all talked about how you're better with your
Yeah. I dropped it.
How do you soccer down?
I can do a rainbow and then
Very
start
good.
juggling.
Me too.
I can do a rainbow.
You can make it up if you want.
Oh, cool.
I can do that too.
What's a rainbow?
I think
Brady, we're in section 5.5.
you have to like put your feet like this or something, like you kick one back and it comes over and you gotta catch it. Stop, baby.
So, distributed. Okay. So you gotta add.
Uh.
Okay. And then you and then you gotta get
did. I already got that.
Very, very good. Okay, slap on the back. Okay, I told you guys about slap on the back. Alright, I'll explain that after I talk through this again here, okay? So, Gracie did a good job. Make sure, hey, let's get all of our variables together first. And here's the thing, when it's negative, when one of them's negative and one of them's positive, we talked about, hey, what's going to be easiest for us, okay? It's going to be easier to subtract 8 and make it more negative, or add 6 and keep it positive. Keep it positive. So we move the 6 over, okay? You could subtract 8s and you can still get the right answer. It's just more work for us, and you know, I'm always a fan of, you know, working smarter rather than just working harder for the heck of it, okay? Okay. Haste makes waste. Yeah, don't go too quickly. Think about, oh, what should I do? Oh, okay. Adding success will make it easier, okay? Then we got our numbers together after we got our variables together. Then we're ready to divide to undo that 14. Multiplying with s. Questions? Okay, slap on the back story, okay? So I have some friends, believe it or not, I do have friends, okay? I don't even have to pay them that much to my friends. Only $20 a week. It's a pretty good deal, really, okay? Best one I've found in a while. Now, these friends, you know, okay, one of them, you know, they did something good one time when we were eating lunch, and, you know, normal people, you know, when you do something good, you give yourself like a pat on the back, right? And you go, you know, good job, self, you know, or like, you know, that's a common expression, right? Give yourself a pat on the back, okay? This person does this, okay? Isn't that like unnecessarily violent and aggressive? It's like a slap on the back. So like, you just slap your back? And like, yeah. They're like, what? And so since then, and attaboy is what you said? So since then, I've called it slap on the back. So whatever I say, instead of giving yourself a pat on the back, I'll say, hey Gracie, good job. Give yourself a slap on the back. Remember, like stretch out a bit. Like if you can like pulse on, that's pretty aggressive. You know, just violently fling your arm over your back. Okay, I like to exaggerate, but I can do like my whole body into it as well. Okay, questions on that?
Not on the slap on the back. Do you want us to do number 2?
I do want you to do number 2 as well. This is what's going to happen, guys, okay? So, number 2, you get to distribute this once or how many times? Twice. Once on this side, once on this side. Now, I want you guys, this will be your homework, okay? You finish now, do you have any homework then? Heck no! And you have me here to help you.
We have a 3-day weekend.
Okay? And we have a 3-day weekend. That's lit, right?
Pretty hyped about that.
Okay, that is hype. No school Monday, Labor Day, boy.
No school Friday.
Yeah, and then no school next Friday either because Harvest Festival.
Oh my gosh.
Wow, 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 like the airport, right? Wow, wow, okay. So let's work on number 2 here. Let's work on number 2 here, okay? Yeah, I can come over and help you with that.
Okay. Since I'm adding maybe 8 and I would just say 7.
How did it become 1? It was negative 2 times.
Oh my gosh. My
Do I do like 7?
Yeah. So we call distributing is where
Taylor
we
Hardesty,
The
Owens Van Hola,
So,
Andy
every teacher
Montez,
comes to this, right?
just remember.
Montez,
Yeah.
Your teacher's
Alexa Gibson, Carly Blackwell, William Robert, Kylie Kaiser, Dakota Hill, Emily Gunter, Dwayne Wilson, Landon Seabury, and Sophia O'Shea. Please come to the office after the bell.
And then from there, we solve like we were up here, which we said was we first have to get all the variables together, and then I get all the numbers together. Yeah, but here's the thing.
Yeah.
Before, we could just combine them, but now they're on different sides of the equal sign. So we have to move one across the other. So we say we would rather move 2n, negative 2n, rather than move 7 and negative 2. Yeah, because you add, we like adding. Subtracting usually.
Oh, okay. Oh yeah, because it's not on the bottom.
N equals. Is it?
You end up getting a fraction.
You actually did.
What?
Yeah, so you have this right. So how do you get rid of this?
Divide.
So it's 1 divided by 9.
Isn't it just 1?
1 over
1, 9?
Wait, 5 close. So
Sure.
7 plus 2.
Does anyone shoot their Shit, no.
I did.
That's the only
What you
change.
did,
Stuff's here. Boom. Okay, hey, have a great 3-day weekend, guys. You ready, by the way?
3-day weekend.
Secret football play for tonight. Okay? Coach is having a signal. They're going to give it to me. I'm going to show 'em my socks. I'm going to run the play. I'm going to get that done.
Of course.
I'm split.
I know that's the only reason you got out of bed this morning, so.
Come on.
Hey, have a great lunch and/or class, guys.